When you're sitting on a plane waiting to take off, have you ever actually thought about what's literally holding you up? That simple-looking strip of pavement is one of the most complex and honestly fascinating pieces of engineering out there. So let's peel back the layers and see what's really going on.
You guessed it, it's the runway. It has to put up with just incredible forces, crazy temperature swings, and the nonstop stress of planes landing and taking off. The story of how we got from a simple grassy field to these high-tech marvels is, well, pretty amazing.
I mean, in the beginning, it was as humble as it gets. The Wright brothers, they literally launched from a cow pasture with a wooden rail. Fast forward just about 20 years, and you have Henry Ford, a pioneer in so many ways, building what people called the first modern airport. But even that started with grass runways. It wasn't until 1928 that he laid down the first ever paved concrete runway. That one move was a total game changer, setting the stage for the massive infrastructure we have today. And when we talk about the scale of this modern infrastructure, it's truly mind-boggling. This is not just a long road. It's a monumental feat of civil engineering.
Yep, you're seeing that right. Building a single modern commercial airport runway can cost over $8 billion. That price tag alone should tell you just how critical and incredibly complex these things are. So what on earth goes into that cost? Well, what you're paying for is a super sophisticated system designed to handle immense stress. It's so much more than just a road. It's an engineered structure built in layers, literally from the ground up. It all starts with the subgrade. This is basically the native ground, the soil the airport is built on. Engineers spend a ton of time testing it, compacting it, and getting it perfectly prepared to be a stable foundation. Because if the subgrade shifts or settles even a tiny bit, the whole runway on top of it can crack and fail. It has to be perfect. Okay, so on top of that perfect subgrade, you build the pavement system. Think of it like a multi-layer cake that's designed to hold up a 400-ton elephant. You've got a thick base course, usually made of crushed rock, and then finally, the surface course, the part the plane actually touches. Every single layer is engineered to do one thing: spread out the massive, focused weight of an aircraft so nothing breaks. Now this is where it gets really interesting. For that top layer, there are two main philosophies. On one hand, you've got concrete, or rigid pavement. It acts like a stiff, unbending slab, spreading the plane's weight over a huge area. Then you have asphalt, or flexible pavement. It does something totally different. It acts more like a tough blanket, actually bending slightly to pass the load down to the layers below. Two completely different solutions for the exact same problem. But here's the thing. The weight of a jumbo jet isn't the only force these runways are fighting. They are in a constant, silent battle with a much more subtle enemy: the daily changes in temperature. To really understand this battle, some researchers at Taiwan's Chiang Kai-shek International Airport did something incredible. They went and embedded sensors directly inside the massive concrete slabs of a taxiway. They wanted to measure exactly how they moved and stressed as the temperature changed throughout the day and year. And this chart shows exactly what they found. It's wild. As the air temperature drops at night, the concrete actually shrinks, and the gap between the slabs, that's called the joint, it literally opens up. Then, as the sun comes up and beats down on the pavement, the concrete expands and the joint closes shut. The runway is literally breathing in and out every single day. And this breathing creates these enormous internal stresses. In the summer heat, those expanding slabs are pushing against each other with a force of over 40 kilograms per square centimeter. In the winter cold, they're trying to pull themselves apart. The real engineering magic is creating a material that can withstand this constant cycle of pushing and pulling for decades without falling apart. So if you've got this massive breathing structure, how do you check its health? You can't just shut down a runway for weeks to go dig it up. You need a way to see what's going on underneath the surface. And that's the key problem, right? Airports just can't afford to close runways for long periods. The old ways of testing are slow, and you have to destroy part of the runway to do them. The solution is something called non-destructive testing, or NDT. One of the coolest NDT tools is the falling weight deflectometer. It's brilliant. Basically, a huge weight is dropped onto the pavement. Bam! It creates an impulse that's just like an airplane's landing gear hitting the ground. Then, a line of super sensitive sensors measures the ripple effect, the tiny way the pavement bends.
By analyzing the shape of that ripple, engineers can figure out the stiffness of each layer underneath and find hidden weak spots before they become big, dangerous problems. It's like giving the runway an ultrasound.
Now, NDT is amazing, but the next step in runway maintenance takes the human eye out of the loop almost entirely. It's being replaced with something much faster and way more accurate: artificial intelligence. Meet UNet. It's a type of AI called a deep neural network. And what's so fascinating is where it came from. UNet was originally designed for the medical field to do incredibly detailed pattern recognition, like finding tumors in medical images. Some very clever engineers realized that finding a tumor in a lung scan isn't all that different conceptually from finding a crack on a runway. It's all about teaching an AI to spot patterns that we might miss.
But to teach the AI, the researchers had to get creative. They didn't have thousands of drone pictures of runway cracks just lying around. So they created a hybrid dataset. First, they fed the AI a massive public database of crack images taken with regular smartphones. And then they fine-tuned its learning with a smaller, more specific set of drone images from an actual airport. Really smart stuff.
And the results are just stunning. Okay, look here. On the left is the raw picture from the drone. In the middle, that's the ground truth, a map of where the cracks actually are, painstakingly mapped out by a human. And on the right, that's the AI's prediction. I mean, it is almost identical.
Here's another example. Look at how it traces out these complex, sprawling patterns with pixel-perfect precision. This is a job that would take a human inspector hours and hours of really tedious work, and now it can be automated in seconds. This is the future of keeping our infrastructure safe. So the next time you're taxiing for takeoff, maybe glance out the window and appreciate what's underneath you. It's not just a strip of pavement, it's a multi-billion-dollar, multi-layered structure that is constantly breathing with the seasons and, more, is being watched over by incredibly intelligent systems. Which, of course, leaves us with a final thought. Runways are just the start. With this technology proving to be so effective, what's the next critical piece of hidden infrastructure? Bridges, pipelines, dams, that we're going to ask AI to watch over for us.